All right, today we're going to be looking at more dividing with decimals. You should have day 71. All that you needed was dividing with decimals by decimals letter A. You needed this page. We're going to look at this front and back. The rest of the pages you should have left in your binder. The first part we're going to look at is with a number line here. And it says, building a tree house, Henry measured some wood at 3 2/10 feet. He cut the wood into 4/10 of a foot pieces for shingles. How many pieces of wood could he cut from the 3 2/10 feet? So if I do cubes down the side, since this is a word problem, I have to circle my important numbers, 3 2/10, 0 and 4/10. I need to underline my question. How many pieces of wood could he cut from the 3 2/10 feet? And I need to box my key math words. Pieces is one thing I'm looking for. And the wood is measured at this total amount. So if I'm looking at this, I have a piece of wood that is in total, it's 3 2/10 feet long. And I want to slice it into pieces that are 0 and 4/10. And I'm trying to figure out how many of those pieces I can get. So in essence, I'm looking for how many groups of 4/10 I can fit into 3 2/10. So this equation is 3 2/10 divided by 4/10. So if I look at my number line, I need to start by circling my total. So I'm going to circle all the way to 3 2/10. So I circled my total. Notice I went 2 little marks over because there's 10 marks between 3 and 4, so 2/10 would be on the second mark. And now at a time, I'm going to circle 4/10. So I'm going to circle 1, 2, 3, 4/10. There's one group. I'm going to come back and make sure my line lines right up with where I left off. So I'm going to circle 1, 2, 3, 4/10. Line it up again and circle 1, 2, 3, 4/10. Line it up again, circle 1, 2, 3, 4/10. 1, 2, 3, 4/10. 1, 2, 3, 4/10, and circle that. 1, 2, 3, 4/10, circle that. Notice my circles always have a connecting line right there. I'm not skipping a space. If I skip a space, I'll mess up my answer. Okay? 1, 2, 3, and then 4/10. When I look, I have 1, 2, 3, 4, 5, 6, 7, 8 groups. So this equals 8. So it's like 32 tenths divided by 4/10, and that equals 8 wholes. Okay? Let's go ahead and take a look at the second problem. At a store, a bushel of bananas costs $1.35. Individually, each banana costs 15 cents. How many bananas come in a bushel if it costs $1.35? Here's my question. Okay? Bushel is one thing I'm thinking about. That means like the whole thing. And then it says that the whole bushel cost, the total cost is this right here. And each one is 15 cents. So I've got to figure out how many groups of 15 cents are in $1.35. How many bananas, because the banana is worth 15 cents. How many bananas are in this whole $1.35, which makes up a bushel? So I'm going to take $1.35 and divide it by 15 cents. So I'm going to box out my total. $1, 3/10, and 5/100. So I've boxed out my total, and I'm going to shade 15 hundredths at a time. So 1/10, 1, 2, 3, 4, 5. Then remember, I can't skip these 5, so I'm going to shade 1, 2, 3, 4, 5, and another 10th. I'm going to shade 1/10, 1, 2, 3, 4, 5. Then I'm going to shade 1, 2, 3, 4, 5, and another 10th. 1/10, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and another 10th. 1/10, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and another 10th. 1/10, 1, 2, 3, 4, 5. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 groups. So my answer is 9 bananas in a bushel. Okay, it's like thinking If I take groups of 15 cents out of $1.35, how many groups of 15 cents do I get? I get 9 groups. Or 135 hundredths divided by 15 hundredths, I would get 9. Okay? We're going to turn it over to the back. Look at decimal B. Joseph had $1.92 in his wallet. He wanted to buy a couple of gumballs to give to his friends. Each gumball cost 32 cents. How many gumballs can Joseph buy with $1.92? $1.92, 32 cents. Important numbers. How many gumballs can he buy with $1.92? So I want to know about gumballs, and I know each gumball costs that much. And I know this is his total he had in his wallet. So that means I'm going to take his $1.92 and I'm going to divide it by 32 cents to figure out how many gumballs he can buy, because this represents the cost of one gumball, and if I take his total he has and divide it by the cost of one, it'll tell me how many he can actually buy. So I'm going to box out what I need. I need one whole, and I need 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths, and 2 hundredths. There's what I need, so I'm not going to worry about this last little part over here. I'm going to shade in 3 tenths and 2 hundredths at a time. 1, 2, 3, 1, 2 hundredths. Now I've kind of got to get tricky here because I have 8 hundredths here. So I know I need 32 hundredths. So I'm going to shade in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Then I'm going to shade in 32 more hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. And I'm going to shade in 32 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Now I have 2 more here, so I can shade in 1, 2, 3 tenths. Then I can shade in 1, 2, 3 tenths, and 2 more. If I look at my groups, I have 1, 2, yes? Thank you. 3, 4, 5, 6 groups. So my answer is 6 gumballs he can buy. You need to choose one of these 2 problems that you're going to solve. You can use base 10 grids or number lines. There's extra base 10 grids that you should have with you. Make sure you put this in your table of contents as dividing decimals by decimals, and it is 5 MBT 7. Silly saying for today is tomorrow is our last day of this week.